scientist Sulfur.
And I'm physicist
Germanium.
And on this week's episode of Let's Get Physical,
Let's get physical!
Today we are going to take a trip to a physics fanatic's heaven. The Fair!
But more specifically, Area 51.
Alright kiddos, before we go to the fair, we're going to access some background information. The purpose of this experiment is to find variables to plug into some physics equations. You may ask, what are those equations? Here they are. Tangential velocity, tangential acceleration, centripetal acceleration, and angular position. All in first line up and down. Now, numbers we must obtain at the fair to plug into the equations. Initial angular velocity, final angular velocity, angular acceleration, height, radius, and times. Now, onto a visual of the ride. You may say this ride is out of this world. Here, it may look like a diamond, or better known, a spaceship. This is the door. Now, onto the inside of the ride. It kind of looks like a sacrifice, but don't let that scare you. Here in the inside is the operator. They sit there so they won't experience the G-forces. The ride goes in a counterclockwise circle around and around. And the ride is lay against boards. Now, onto the ride.
Now onto the history segment of Let's Get Physical. Wisdom USA first made the Gravitron in 1983, making the iconic ride over 31 years old. That's old. The ride is shaped to look like a spaceship, decorated with metallic colors and lights to advertise the name of the ride. It is made up of 33 kW three-phase motor and has a central booth that consists of a chair designed to keep the operator safe from the G-forces. The inside usually has lights to give it an outer space vibe. The ship is surrounded by 45 panels that suit the average person for riding. This way the ride feels the same from every panel. Each panel is on rollers that naturally rise up when the highest speed is reached due to centrifugal force. As a result, the point when one feels the lightest is at the beginning and at the end of the ride. The heaviest feelings are felt when the boards slide up. Here, the rider experiences 4 Gs. The suggested time for each ride is no more than 80 seconds, although the one at the State Fair lasted about 45 seconds longer. Rule breakers. And the quotient capacity is 40 people per ride. The quotient capacity per day is 5,280 on Tuesday, October 14th, 2014.
I need you to keep your head below the top of the seats. Do not turn upside down or sideways.
Bullseye. height because we measured from the bottom of the ride to the top of the ride. We got the radius because we measured from our center of gravity to the person on the inside. We got the circumference because we plugged the radius into the circumference. We got the diameter because we doubled the diameter. And bada bing, bada boom. Yeah. So then we got the time of the ride by sitting in the ride and taking a timer and laughing at every time we got to time up and time down. We got the angles at which the boards were slanted by obtaining the height from where the board touches the ground to the point where the board touches the ceiling. And then we measured the distance between that point where the height stops and where the board touches the ceiling of the ride. Well, actually, the board, we mean panel. So then we got 59 degrees, and then the maximum velocity we got off the internet. So this is the raw data table. Woohoo! Alright, now it's time for the fun stuff. Ha, just kidding. No, I'm not. Alright, here's what we're trying to find. Here's the equation for what we're trying to find. Here's the variables plugged into these equations so we can get the answers, which are right here in this column. Alright, and this one, we have all the answers when we're sliding up. In this column of answers, we have all the answers when we're sliding down. And at the bottom, we have the angle of the board slant and how we got it.
1, 2, 3, 4. Everybody makes mistakes. Everybody has those days. Oh, yeah. Everybody knows.
Well, Cindy and I messed up quite a bit, so let's find out what exactly we messed up on.
When asking the operators for the measurements that were needed, the answer was, "I don't know nothing," says the woman. As a result, all information had to be based off of one fact, that the ride's maximum velocity was 24 RPMs, which is achieved at slide up. This leaves a lot of room for error from guessing the numbers. Another error was that when measuring for the radius, height, and angle of slant, the numbers might have been short a few inches, probably due to the fact that the tape measures slant slightly when extended beyond a certain point. Want to hear a joke?
Sure.
What's a physicist's favorite thing to do at a sporting event?
Well, I don't know, Scientist Sulfur. What?